And welcome back to video number 2, which is going to be pages 4 through 7. Dr. Conklin and I are here again.
Hi, everyone.
Okay, I'm going to start with number 19. Parallel lines in a transversal. I have them already outlined, and you can see that these are alternate interior angles, which would mean they're going to be equal to each other. And below here I have them showing the algebra setting them equal to each other. 6x plus 42 equals 18x minus 12. I took away 6x from both sides. I end up with 42 equals 12x. When you divide both sides by 12, you get 4.5, which is choice B. Now, the number 20 is a very similar question, but now we have corresponding angles, but yet they're still acute, they're still the same size. So the algebra is the same as the question above. They are still equal to each other. So you would set 5x minus 22 equal to 3x plus 10, and show your work there, and you end up with x being equal to 16.
We're on Peach Street and Cherry Street, and we're told those are parallel. So when we look at this question, we already have these angles highlighted for you. We have angle 1 and angle 2. The first thing I would look at is notice that one of these is acute, angle 1, one is obtuse. So most of the time in geometry, if we're not setting things equal, we're adding things up and setting them equal to 180. These are, actually if we move this angle up, you'd see by corresponding angles, these two angles, 1 and 2, are going to be supplementary. So we add them up, set them equal to 180. When you go ahead and solve, you'll get x equals 17, and then just be careful. Once you have x equals 17, they're asking for angle 1, so you want to make sure to substitute back in for this angle. 2 times 17 plus 36, and that will give you choice D, 70. And then we talked about orientation in our last video, but if you first look at question 22, this is a great SAT type of question because we use process elimination here. How are we getting the pre-image, which is this first one here, to our image? If you notice B and B prime line up, and then it looks like A and A prime flip over. So you want to first start by eliminating choice C and D that have the words translation. And then we know any reflection changes the orientation, but just to remind you, if we look at the orientation this way, we're going clockwise. And then if we go going A to B to C, A to B to C, and then if we go A prime, B prime, C prime for our image, we notice that's going counterclockwise. So the orientation is not the same, which means it's choice B, opposite orientation.
23 asks for which dotted line is not a line of symmetry, which means if you folded along that line, which one would not line up? This one would, this one would, this one would, but if you folded an S, you would end up with it over here, the opposite, the mirror image of it. So it's D would not create a line of symmetry. 24, which letter has both line and point symmetry? Line symmetry is if you can fold it, and point symmetry is if you can spin it 180 degrees and make it look the same. You can fold a B, but you can't spin it. It'll look backwards. You can fold a T, but you can't spin it. It will look backwards. You can spin an S, but you can't fold it, as we saw in the question above. But an H can be folded and upside down. It looks the same. So H has both line and point symmetry. 25 was a question off of the warm-up sheet we did most recently, and when you have a segment parallel to its segment and then you reflect it, its image, choice A, is also going to remain parallel.
Okay, this is Dr. Conklin. We're back. Oh, what's that music I hear?
I believe it's Beyonce.
Yes, very good, Mr. Fields. So if we look at this question, we're going to reflect over the y-axis, which means we're really taking this and reflecting it to the left, sort of.
Oh, I get it. To the left, to the left.
I know. So if we go 2 boxes here, we have to go 2 here, and we're going to sort of repeat that pattern for every problem, making sure that we're the same distance or congruent. Now the key part of this problem is justify your work. So this is always, always on the regions. Now, Mr. Fields, I tell my students if they get this question wrong, I'm going to fine them this summer, make them do math with me. Because
that's your choice.
how do you justify if something's an isometry? An isometry means that shapes are congruent after a transformation. And yes, these shapes are congruent because they are rigid motions, which means anytime you write the word rigid motion, you should also include the definition. So a rigid motion preserves the size and the shape. So somewhere in your definition, you should say yes, and then you should also include the definition of rigid motion here. And then number 27, same idea. We have which produces an image that is not congruent. So what they're asking for here, we know our three transformations that are rigid motions are translation, rotation, and reflection. The only one that is not is going to be choice B, which is our dilation.
And we're back to Mr. Fields for page 6, which I'm going to go really quickly through. I don't have any music that relates to the questions, but most of you know I like 70s and 80s music, so we're playing that in the background a little bit. Number 28, which transformation is not always an isometry? We just talked about that. It would be a dilation. Number 29, same type of thing. Which transformation would result in an image that is not congruent? Again, dilation. Number 30, this one's a little bit different. Be careful because we get in the dilation happy. We always think that one's the one that's different, but this one shows it being a reflection, which is not preserved in a reflection. We talked about that a couple pages ago. Orientation is not preserved in a reflection. Dr. Conklin drew the counterclockwise and clockwise circles to show that that was true. Number 31, what's happening here? It looks like it would be a rotation. Number 32, same thing again. It would be a rotation. That's the entire page.
Hi, this is Dr. Conklin. We're going to talk this one out. Get it? The song. It's called Talk, Mr. Fields.
Ah!
Get it? All right, so this is a mid-segment question. I got to put Lita on pause. Too loud. So a mid-segment, we know, is parallel to the base. They are not congruent, so always just use your eye to check. This is always half the distance, D to E, of A to C. So I'm going to double that and make it 14. And then perimeter, we know, is when we add all the sides up. So if we do 10 plus 13 plus 14, we will get a perimeter of 37 for the big triangle ABC. And then the same idea here, equilateral triangle. We have all sides congruent, and also a good tip for the midterm is if you guys remember, every angle in equilateral triangle is 60 degrees. Not helpful for this problem, but helpful in general. So if we know triangle ABC has a perimeter of 36, that means each side has to be 12. And then we're asked to find E to F. So if I highlight E to F, that's this piece right here. We can break this down even further since we have midpoints. So these are going to be 6 and 6, which means that this triangle right here, where we wanted to find E to F, has to have all sides of measurement 6. So E to F has to be 6 as well. If we look at this triangle, we're trying to find the perimeter of another trapezoid. So let's first outline the trapezoid. A, B, E, and F. And again, since we have midpoints all around the sides here, I'm going to do half of 16 is 8, half of 12 is 6. This base piece here is 20, and since EF is a mid-segment, we're going to do half that to get 10. So we're going to do 10 plus, let me outline it for you guys. We're going 10 plus 6 plus all the way to the base 20 plus 8. And when we add all those up, we should get choice D, 44. And then last but not least, this one's a little bit tricky. So we have a mid-segment here on the top and parallel to the base. These are the only pieces of information we're given. I like to start these questions off by first setting these two segments equal to each other. So 3x plus 1 equals 7x minus 3. Now you're saying to yourself, that, oh, this is crazy. These are not equal. These are different measurements. What do I have to do to AB to be the same measurement? Well, how many ABs fit into the base VW? Well, if you remember your rules of midpoint and mid-segments, the smaller piece fits 2 times into the base. So what we're going to do is take the smaller piece and multiply it by 2. When you use distributive property, multiply it out, you should get x equals 5. Once you have x equals 5, do you see how they're trying to trick you here? The answer is not 5 because they want you to find v to c. So make sure to substitute back in. And you will get 32 for this whole piece, but then v to c is only half of it. So your answer should be C16.